Okay, and we are live. Hello, everybody, and welcome to AWE Night SF. I think just giving it probably one more minute for the last people to trickle in, but we're going to get started here in just a second. And we got a great show for you. So just hang tight for another 30 seconds as people start to trickle in because we are live and in action. One of the things before we get started is I really want to invite everybody to use the chat, ask questions, and so like even starting, like I think one of the great things about AWE Night when we're in person is the community and the networking and speaking with each other. So let's try to do that today. And there's obviously networking capabilities on the platform, but feel free to introduce yourself in the chat. I'm going to be in there. I'm going to be speaking with everybody. So, maybe drop your name, if, your experience in AR, and, what excites you about the chat today. So, okay, let's go ahead and get started. So for those who haven't heard, this is AWE Night SF. This is our second AWE live event. So we are hopefully going to have ironed out more of the bugs from the first one, and we're going to be off to the races on this one. Today we've got a great show ahead of us. We are going to be focusing on 3D mapping, and we are here with one of the hottest AR companies in the world right now, which is Niantic. And we're going to be doing a talk with Myoung and Brian, and we'll be getting to that to just a second here. But my name is Patrick. I'm co-organizer of AWE Night SF and CEO of Rock Paper Reality. Before we get started, in the chat, like how many of you have actually been to an AWE live event before? Okay. And I don't know if any of you have been to an AWE Night SF before, but love to kind of hear if you have. The good news is that soon we'll be back and doing a few more in-person shows. So things are starting to open back up again. We're starting to talk to some of our vendors, but ideally we will be doing more in-person shows in the coming months, and not only just online. So I'd love to kind of go back and see more of you again in person. AWE Night SF is part of the Greater Augmented World Expo family, and it's the world's #1 spatial computing event series with conferences and expos including US, Europe, and Asia, and supports 16 independently run AWE nights around the world. Those were all kind of listed in the slide above. So check them out now that everything is online. I just go on and graze through all the other chapters. There's tons of great speakers and content all around the world now. As you can see here, AWE is back in action in Santa Clara on June 1st and 3rd. Get your tickets now, and very excited to be there. I'll be there. I'm in actually Scotland right now, and I'll be flying in just for the show. It's going to be a good one, and so definitely go in and get your tickets. And if you ask in the chat or send us a message, I'm sure we can probably find you some discounts here or there. So I think, what do we got? One more slide after this, Myoung? Right, the social part of it. This part's important. So I would love if everybody hits us up on social, Twitter, hashtag AWE Night SF. We are trying to spread the word, build up our community. I've been saying this forever, but we're really close to that 5,000 mark. So help us get over that hump. I think we literally need like 10 people now. So tell your friends, it would be much appreciated. And let's see, are we right? And then of course the academies. So then AWE now has their own academy series. I teach the Web AR Workshop one every maybe twice a year. There's also one on fundraising prep courses for startups, a HoloLens course, and an XR virtual collaboration workshop. They're great. They're well worth the money, and be sure to to also check them out. Okay, I think that is us. So right now I'd like to welcome Brian McClendon, Senior VP of Engineering at Niantic, for a quick talk on 3D mapping, a bit about their augmented reality development platform, and just to kind of get into a bit of the work that you've been doing forever, Brian. So welcome to AW Nite SF. Really excited to have you. Love to kind of hear more about what you've got in store for us today.
So I'm going to do, I'm going to do a brief introduction. Hi, everyone. Welcome. We have an exciting event for you today. With us is Brian McClendon, as Patrick mentioned, who is the Senior Vice President of Engineering at Niantic. He has been involved in 3D and 3D mapping for a few decades. First working on hardware at Silicon Graphics, then started a company called Keyhole, developing geospatial data visualization. Keyhole was later acquired by Google, and the products eventually became Google Maps, Google Earth, and Street View. And I believe he also worked on SketchUp, which is a 3D modeling application, which I'm very familiar with coming from architecture and 3D modeling world. Then Brian went to work at Uber, developing self-driving autonomous vehicles as their VP of Maps and Business Platforms. He currently resides in Lawrence, Kansas, and is very active in his community, including running for Kansas Secretary of State. He is also currently an adjunct professor at University of Kansas, venture partner at UP Ventures, and also an active supporter and mentor for the local startup community. So we know that you're a very busy person, so we really appreciate you giving us your time today. And I know you have a brief presentation for us, so I'm going to hand the floor over to you.
Okay, sounds good. So apologies in advance for my network connection. It has been perfect 4 months, and of course, about 15-20 minutes ago, I noticed some poor performance. So I'll keep an eye on it, and hopefully it won't be too bad. So anyway, thank you for the welcome, Myoung, and I'll explain a little bit more about my background and why it's sort of relevant to the conversation of 3D maps. I started, in the 8 years at Silicon Graphics was really all about hardware and software for 3D back when 3D was incredibly expensive. And just for those in the AW community who look back far enough, we did do virtual reality back in Silicon Graphics using these incredibly expensive counterweighted headsets that Disney Quest actually set up using our very expensive machines. So we were very early on. Jaron Lanier did a bunch of work on our machines early on. So I got to see the beginnings of VR and thought it was the next big thing back in the 90s. But as we know, that was a bit early. And the biggest reason was computer graphics hardware was expensive. So what we discovered was that prices were coming down, PCs were coming, and we started a company called Intrinsic Graphics, which is middleware for games. And the thesis was we could help make cross-platform games highly performant on PlayStation 2 and Xbox and GameCube and PC. And our first demo for that was at the beginnings of what became Google Earth. And so we did a great demo, which is a zooming visualization from outer space down to terrain model of the Bay Area, and showed that you could run this now not just on Silicon Graphics machines, but also on PCs. And that demo got us funded, both for Intrinsic and also for the spin-off company that became Keyhole. And we continued to build the middleware for games that was eventually acquired by Activision, and the Keyhole company was eventually acquired by Google. And Keyhole was trying to be a 3D globe and mapping company, but as a startup, you find that data for geospatial data is very expensive. And so when Google offered to buy us, Larry Page made us a promise we couldn't refuse, which was that he would pay for all the satellite imagery we could serve. And it turns out, unlike many acquisition promises, he followed through on it. And we were able to collect a lot of satellite imagery from what is now Maxar and others, and integrate that into a 3D globe, launch it as a free product called Google Earth, and start to build this 3D world on top of it. At the same time, other teams under me were building Google Maps and then putting satellite imagery into Google Maps and starting to collect Street View data. And this turns out to be very relevant to recent conversations. So Street View is initially really just a user experience. So collect a 360-degree image and let users visit places they haven't been by dropping into a 360 view. And that was great. People loved it. But the first thing they noticed was they would drop into a 360 view of a street or location and our data was wrong. Map data was incorrect. And that was because we had licensed map data from the best map providers out there, and it wasn't very good. And this led us to start creating our own maps using the fact that we had already driven Street View for many places, and we continue to drive more. And that was the basis for how Google Maps data became actually the strongest differentiating factor and made us successful, I think, as a map provider. We continue to increase the quality of our 3D data. Initially, we bought SketchUp, as Myoung mentioned, and we bought the company in 2006, and we made the product free. And this allowed for people who had an architecture background to model existing 3D buildings and place them in Google Earth. But it turned out that even though we got a lot of user-generated content, it didn't scale. And so we were already collecting aerial imagery from airplanes, but we made a more systemic effort to collect high-density aerial imagery across many cities and then figure out, could we generate 3D buildings from that? And the 3D buildings you experience in Google Earth today are derived from that aerial imagery and not from SketchUp. We eventually sold SketchUp to Trimble in 2012. But in any case, the 3D buildings, when you can do them algorithmically, it is much easier to make them scale. But if you notice, the quality of the 3D buildings is not as good as you'd like down at street level. And that's been one of the challenges, I think, that Google and others have struggled with, is how to have a unified, high-quality image set. When I went to Uber, I realized that all of the maps that we had built to date had not been good enough. And it turns out that self-driving cars need maps much, much higher precision than what Google Maps was capable of. And one of the reasons they need this is that GPS, A, doesn't work very well, and B, does not work at all underground and in parking garages and many other places that cars must work. So the first thing that Waymo and Uber and Cruise started doing was building very high resolution maps for localization purposes, for helping car find where it was in the world. And so these maps were a revelation to me, because they required lots of LiDAR and lots of imagery and a lot of combinations together to provide a high quality map. But there, you could only do one city at a time. Even a single city was insanely large. So if you're wondering why Waymo and Cruise and so forth are only driving in a couple of cities right now with their self-driving cars, maps are actually one of the limiting factors. And so, how do you make high-resolution maps at scale? Well, after a lot of discussion and working with my old colleague John Henke, he hired me to lead the augmented reality group at Niantic Labs and work on the ARDK, the development kit for Unity that some of you are probably familiar with, the VPS mapping service that is going to be announced here very soon, but has already been pre-announced enough that when Google's came out yesterday, we were compared to it. And I'm also leading the AR research group, and we also bought Eighth Wall, which is another company probably close to the hearts of several of you, as a easy web access mode to enable AR around the world. So, my focus has always been on building high resolution 3D maps for many purposes. And now that I'm at Niantic and watching how real users want to interact with the world at precision, we are working on building a system that will enable that. And I'm happy to answer any questions about about our products and about my path as you see fit.
Thank you so much. that was a great introduction to what you've been working on and some of the history behind mapping. But, as someone coming from architecture and design in the physical world, Google Maps has always been an incredibly powerful tool for architects to help in their efforts to design useful and meaningful places. So on behalf of many architects, we thank you. So I do have some questions for you before we head on to Q&A from the audience. And so my first question is, it's about the different approach to mapping that Niantic is doing, which I'm assuming is primarily crowdsourced mapping versus Google and Apple's approach, which is more system-wide mapping that maps entire cities and regions. So what do you think are the advantages of Niantic's approaches?
Well, in general, because users are contributing it, you're getting data where users go. With Google and Apple, you're getting data exactly where their cars choose to go. And cars can go a lot of places, but they can't actually go into many of the places that people spend their time. Parks and fields and things away from the roads themselves. And yes, there are some methods that Google does with the backpack to try to reach into areas like that, but their coverage is relatively shallow and is old at best, because they usually only do that once. And so one of our other advantages is that we're continuously getting updated data from our users.
I see. So where are you guys collecting data from some of your apps like Ingress and Pokemon Go? Is that how you guys are curating some of the mapping?
Yeah, so the game players actually choose to create scans, which are effectively videos that they collect around places of interest and specific, what we call, Niantic way spots.
I see. So if you are interested in a particular spot that it's not available through VPS, through Lightship, then is it possible for the user to scan that particular area to add to the map, so to speak, and become available?
So at the moment, we are focused mostly on things where there's existing gameplay or existing game locations. So the data we're collecting is, there are millions of these, so it's not like it's low coverage, but it is focused at sort of outdoor congregating game-like areas,
including like semi-public spaces as well, like museums or like outdoor spaces that don't have access to streets, I guess.
Especially those, yeah.
Yeah, so my next question actually comes from the engineers at Rock Paper Reality, and their question is, neural radiance field is a hot topic. What is Niantic's take on this as a short, mid, long-range term solution or potential?
I'm sorry, you said, what was the first word?
Neural radiance fields as a hot topic. What is Niantic's take on this as a short, mid, long-term solution or potential?
So from my reading and looking at the data, I think that the reconstructions we're seeing from some of the latest NERF tools are pretty amazing. They are very much focused on believability over accuracy. And so from a like I would say from a VR experience, they're great. From an AR experience, maybe not as much, in the sense that you can synthesize a believable world that is very similar to the world that we see, but NERF does not give any guarantees that it's actually reality. It's the neural net generates the data, and it's flexible in its definition of what it generates. And the other aspect is we don't know. I've never seen a good report on the geometric accuracy, which is something that augmented reality doesn't really have a choice about.
And can you use that for relocalizing content anyway? So,
no, I mean, I don't think so. I think that you can certainly neural nets, yes, but neural radiance fields are much more about sort of recreating a geometric world from a large set of video streaming inputs. And certainly the demos I've seen are all about sort of visualization rather than reconstruction.
I see.
There are some geometry reconstructions, but I haven't seen precision tests on those.
So it's not really an effective tool for AR purposes.
Certainly at this moment, no. I don't think it's it hasn't been applied anywhere. But I think it has the possibilities of getting applied in this area. But it would have to be a different kind of Nerf field. It would have to be focused on geometric accuracy rather than visual quality. Because I think that all of the Nerf demos I've seen are very much about, does it look real, from a human acceptability perspective, not is it accurate.
Right. Okay. And so my other question is, how do you decide, as leadership in engineering, which features and capabilities to prioritize for your platform? Like, what real world problems do you look at to draw good use cases for AR to fuel the capabilities for this technology? And where do you draw your inspiration outside of games and game mechanics?
I think my personal inspiration is always, I've had a long time desire to accurately map the world, and this need to do it at the level of precision of a VPS or of a semantic labeling system is much higher than any map that's ever been done before. And so some of the work that Niantic does around semantic mapping and semantic scene labeling is, I think, sort of fundamental to long-term, not just games, but also how you interact with the world. Where, as you visualize information on top of the world, you really need to know what the world is underneath it. It can't just be pixels. The computer is not smart enough to take a frame in at 60 hertz and deduce accurately everything about it. You need hints. And there's all sorts of work on sort of speeding the perception work. And this is a big challenge with self-driving cars, right? They need to recognize the world around them 10 times a second. They can't do that unless they subtract the background from it. They're not smart enough to do it for every pixel, but if you figure out what is street and what is grass, then only the moving cars and the people and the mysterious moving objects become things that need to be recognized. And that actually reduces the problem down to something that computers can do in real time. And so I think that kind of problem is going to be true on glasses 10 years from now for how we interact with the world.
So speaking of that, I had a question about in architecture, like most modern buildings that are being built today, there is a digital twin. They design those buildings first and then typically in Revit. But what happens once these buildings are constructed is that there's a broken feedback loop in terms of, because you're never designing a building that's exactly the way it was originally built in a digital format. So, but a lot of times there's a broken feedback loop so that these updates as you construct a building and modifications happen, it doesn't get fed back into this digital model. And then there's a disconnect between the reality and what's this sort of digital twin. So my question is like, our planet is a very dynamic place. Our cities are very dynamic and our buildings are very dynamic. They're not a static structure. And so they're changing constantly, or they're not even having an accuracy. So how do you start to provide this sort of accuracy to the map of the world or map of our cities?
Well, so I think one of the inputs you need is input of timely change. And so the problem that maps had, not architects, because that's an even harder problem. But maps themselves were always out of date because humanity was changing things, right? And whether it was building a new road, changing the direction of one-way traffic, which is very important, and this is much more common and something Google fought very hard to get right, and they're good, but they're not great, is that local businesses are created and destroyed with regularity. And in a normal world, circa 2015, businesses were created and destroyed at about 10 to 20% per year. So out of all existing businesses, 20% go away and 20% come back, because the net is about zero, maybe a little bit of growth, but approximately zero. But 20% change is huge. So having a managed local database of all the businesses in the world is something Google tried very hard to do and took all sorts of inputs to try and get it right. But that was a lot of change to track. And then COVID hit, and now it's 30% or more are going through this cycle because COVID has just crushed a bunch of businesses. So just that simple aspect of the world changing was a huge challenge for Google that, even to date, they haven't fully solved, but I think they're better, honestly, at this than everybody else, including Foursquare. But the future that we're talking about is harder still. Streets don't move very often, but the cones or the median markers move with regularity. Obviously, parked cars move all the time, and storefronts regularly change the layout of the tables and the things on this, signs on the storefronts. All of that temporal data is going to need to be detected and collected. And at the moment, there isn't a system to do that. I wouldn't say we have a solution to that, but it's something that will eventually have to get solved. Is how do you detect and reflect change in, as you call it, the digital twin of the world?
Okay, great. So I started following you on Twitter, and I saw your reply to a post about Apple Maps, and you stated that for the amount they invested, it should be perfect. So I'm assuming that you don't think Apple Map is perfect. So my question is, what is your definition of a perfect map?
Yeah, that's a hard question. The perfect map is one that reflects accurately and can answer all the questions that users have about it and is kept up to date. As I've discovered, there are many levels of data depth and quality, right? So getting the street geometry correct, I think OSM has mostly got that right in most places. So that's a solved problem. Getting the street names correct, OSM's done pretty good, not as good. Apple's done completely fine. And Google, with a lot of work, has done, I think, very well. The next hard problem that Google had was, addresses. And this is where I continue to say Apple has failed, which is that Apple has still not systemically solved the street address problem. And so when you navigate to an address in Apple Maps, it might be right, it might not. And the reason is it's a very hard problem, and Google has documented how Google did it, and Apple has certainly spent enough money on data collection to have solved it, but they haven't solved it. And I just think Apple is inefficient in its use of money.
So given that, now we have all these different platforms, I can deploy separate experiences on using Apple's VPS and their geo anchors and be able to create experiences within that ecosystem or their walled garden. And now, Google just announced their geospatial API, and you can create separate experiences within that ecosystem, and then Niantic's ecosystem as and Snap's do their custom landmarkers and whatnot. So where is it possible to one day be able to create a view of this? I think it's going to be somewhat problematic having all these separate ecosystems. Is there a way to create a view of all of these different disparate maps and be able to sort of tap into the intelligence and the experiences built into these separate mapping systems?
It's the same kind of problem that historically we had TomTom and Here Maps and Google Maps, and they each back when Google started, they each had strengths and weaknesses. I would argue at this point Google is superior enough to both of them that there's not a lot of value add from the other two. Apple Maps has done some work that is outside of what Google's doing in a couple of areas. There's a few things missing from, that Apple has tried to do that Google doesn't, but the reverse is, clearly more true. When we get into this land of localization or VPS, it's very, very early days. And I would say that, none of the three of the systems you just mentioned, or four, if you include Snap, none of them actually do anything directly comparable. They all actually attack the problem very differently. Apple certainly doesn't use any geo-specific data at all. They just, you make your own little map. Google has just announced a new product that uses some existing data set to do a particular kind of localization at a particular level of quality that is not generalizable. Snap is very focused on their in-Snap experience, and it's very hard, maybe unless you compile a Snap camera, it's not clear that you can get some of these capabilities outside of a Snap shader, not shader, lens. There we go.
Lens, yeah.
And then with Niantic, we offer it in Unity on iOS and Android, and we offer it on web with 8th Wall. And so, in the grand scheme of things, for what we're doing, we are cross-platform. But again, we're not solving at the moment the same problems that any of the other three are. And so, I think your ask is reasonable, but this industry is way too nascent to be close to combining them, unfortunately.
Right. Yeah, I mean, one of the advantages I see with because I was a beta tester for 6D, and just the fact that you can do geo anchors like with in Xcode and with Apple products, but you can't. You have to have a LiDAR capabilities on your camera, as well as you can't do scene reconstruction, which is provides occlusion. So, like I look at products like Niantic or Lightship and see sort of those advantages as cross-platform. You can do occlusion without a LiDAR camera, and you can do VPS at the same time, because you can't do VPS and scene reconstruction like in the Apple ecosystem. So it's really interesting to see how all this will evolve. My last question actually is, as someone who's sort of built 3D maps and sort of the mapping capabilities, and as the technology evolves, what do you feel are some of the possible dangers of this technology? I mean, is there anything that keeps you up at night?
There definitely is. I mean, data collection for maps has always had the concern about privacy, right? And when I was at Google, very familiar with all sorts of issues with, street view data and face blurring and building blurring in Germany. And, obviously certain countries wanted us to blur satellite imagery, which we never did. But certain countries would not let us fly airplanes where they didn't want us to fly airplanes. And so if you wonder why there isn't 3D buildings in certain locations, it's because the government wouldn't let us fly there. So definitely there are, people with too many concerns. And then there's the real concerns. For example, self-driving cars in their current form run with 4, 6, or 8 cameras and LiDAR in continuous mode. And if they collect that data and then upload it, which they are doing actually right now to create those maps, but if they did that continuously as a service, for example, if Waymo was doing that continuously and storing it, Waymo could become effectively a perfect police camera for the entire city of Phoenix. And so I'm very sure that they're not actually storing and retaining all of that data. They do not want to be in that situation. But the problem with much of the data collection and AR is this, is how much data do you get and how much do you keep, and for how long do you keep it? And so one of the things Niantic does, we do get these scans the users, opt into sending to us, we immediately blur all faces and license plates. So we do not store anything with faces in it, even before we start processing it to make maps. And I think that the advantages of mapping with LiDAR and even radar someday is that that data is much less privacy invasive. Unfortunately, it still probably does allow for identifying people based on how they walk or other mechanisms, but I think that it's less likely to be used as a criminal, a pre-crime activity, which just is pretty horrifying.
Yeah, I was just actually reading this morning that someone was saying that that City of San Francisco was using Waymo or the police department was using the self-driving cars to collect and survey the city and the people. So it's really kind of interesting. So, I mean, from engineering perspective, is there any way to sort of mitigate that? I mean, and you mentioned something,
So I think that there will be a premium placed eventually on device deconstruction and rebaking of data so that it is still useful for its map creation or correction or updating purpose, but it's not useful for anything personally identifiable. And near as I can tell, that algorithm does not yet exist, but I predict it will be invented.
Okay, great. So that's all the questions I have for you. I know we have some audience questions or some of the panel questions. So.
Hey, Myoung, and hi, Brian. So I will remind the audience to ask questions in the chat, and we'll be curating them, and I can lob them over to Myoung in the background. But I'll ask a few questions just to get the ball rolling. We don't have any yet, but fascinating discussion. Brian, I'm wondering, sort of boiling all of that down to some sort of practical use cases, what are you all excited about for developers to sort of run with Lightship in terms of use cases, and particularly around multi-user interactions? We all are familiar with the ability for our devices to sort of localize within a space and do cool things, but what additional value is going to be unlocked when we have, utilizing your world mesh for persistent graphics and many people being able to do things at once and network effects being formed? What are you excited about there?
You stated a lot of it right in the question. I think multiplayer is a big deal, and I think that localization applied to multiplayer, the challenge right now with most multiplayer is you have to create the map before you use the map, and that greatly limits its excitement. But once you have high quality localization maps, then having multiple players localizing very quickly and very precisely in a location allows for much better interactive experiences. And the other aspect, of course, is consistency over time, the ability to store objects in a particular place and come back and it's really exactly there. And that's one of the hardest problems is if a localization service is not few centimeter accurate, then the object is not going to be in the right place. And I think what you can do with that radically, how good the quality has radically changed gameplay and experiences that can be created, and the feeling once you're in the room, in the outdoor room, of using it.
That's fascinating. Another question that really builds on what you guys were talking about in some of the mapping challenges, where are the sort of unsolved problems where there are still opportunities for lots of mapping data innovation? One that always comes to mind for me is the Z-axis or elevation. What are some of those other areas, whether it's that or something else, that you're excited for the underlying tech to evolve?
I think that there is a very hard problem that it's kind of hard to really qualify this. Once you get to a level of precision like self-driving cars and a high quality VPS get to, you can no longer use GPS coordinates because WGS84 is not consistently accurate enough and especially over time. And, you know, for those of you who study GIS and know about state planes, the reason there are multiple coordinate systems in many cases is because they're chasing tectonic plates. They are chasing the motion of the Earth. And we have seen that if you get it wrong, you can be wrong by quite a bit. So, sorry. Apologize for this.
That's okay. Another question that's related to that is the underlying mapping data as it evolves. You mentioned GPS, right? And we're hearing a lot about 5G and its sort of advantages when it comes to like speed and low latency. But another potential 5G advantage could be location precision, because it's inherently a low range, high frequency signal that can enable devices to have sort of millimeter level precision as they walk around. So I guess the question all boils down to is, does 5G come into your plans as you continue to sort of refine the underlying location data accuracy?
Not in the near term, because while there's a lot of talk of that, like any technology, until it proliferates, it doesn't matter to end users. And so, like when we were building Google Earth, not everybody had a 3D graphics card, or in fact, very few people had one. And so we had to wait for the business to, it took years from the time we showed it to the time it was popular, because that's how long the penetration was. 5G location, I don't think any single person on the planet owns a phone that does that yet. And
Right.
it's nice in theory, but there's no service that provides. And even when it does, will it be universal? Will every 5G phone have it? No. Will every 5G phone with the right Qualcomm chip have it? Maybe. Will the service provide the right sort of metadata for the location? Who knows? I'm cynical, as you can tell.
But you're right, it might be a moot point at this stage because the penetration from a hardware perspective just isn't even there yet. So very good point. Myoung, I don't know if you have any other questions, or we can wrap soon. Brian, I want to hear from you also about your upcoming event and what we can expect there. But Myoung, I want to give you the last word, or any last questions you have.
No, I think I asked all the questions that I had for Brian. But yeah, I think my last statement was going to be to find out a little bit more about the developers conference coming up into this month and what to expect. I haven't registered yet. I'm thinking about it. So what can you say to convince me to actually attend?
Well, I think you'll find that the venue is very good. It's got a lot of outdoor spaces, which will be relatively safe, relatively speaking, safe during COVID times. It has you'll have the ability to experience, interact with I think a level of experience that you haven't seen before. We are going to announce the next version of our AR development kit that will be called 2.0, and it has a set of features in it, and I think you will see some very interesting applications of it, and also a lot of very deep technical talks from my team. I think at least 15 of the people working for me have sessions as part of this. And so it's going to be very much focused on AR and very much focused on location. And, we'll have great talks on semantic mapping and many of the other sort of novel features of Niantic's Lightship platform.
Actually, I
for our audiences.
Sorry, I do have more questions. So one of the things that I've been sort of experimenting with, like snap lenses, custom landmarkers for projects that I'm working on that require more specific sort of object scanning outdoors. So I couldn't find where I could do something similar with Lightship. Are you able to, if you want to build experiences on top of Lightship, do you just use more like the semantic mapping and occlusion to interact with the environment, or can you actually use specific location and bring in that mesh to create experiences on top of that can be deployed through your apps or experiences?
So it's a part of that I can't answer until the 24th.
Okay.
But the idea of scanning models. So are you familiar with Scaniverse? So Scaniverse is an iPhone 3D scanning app. So
yeah.
Didn't
and
Niantic
so
buy that company?
We did, in fact. It was written by a friend of mine named Keith Ito, and he's an awesome, one of the best engineers in the world, who also built most of the GMM navigation work. So he's a rock star engineer, and he is now working for us, both continuing to support Scaniverse, but also helping solve some of the problems that you asked about.
Great. Yeah.
So,
go ahead.
Go ahead. Well, okay, I'll say it really quickly. I don't want to get stray too far away from the event details, just for the context of our audience, just more of the metadata of the event itself, date, where they can find out more, etc.
Okay, yeah, well, I'm not a marketer, but I'll do my best. So if you
well, I think you just mentioned the date. It's the 24th. They could probably find it with a Google search. You don't need to name the URL. That's quite all right.
Well, it's on the Niantic Lightship dev site, and the summit. Yeah, you should be able to sign up for it, and there's multiple tracks. John Henke will give a keynote. I will give a speech at the end, and there will be many more interesting talks in between.
There'll be a virtual and in-person component? Virtual and in-person component?
Certainly. So John's keynote will be live streamed, so you can watch that for sure. The rest of the sessions will be published online a few days after, so not live.
Cool.
But it is an in-person.
Myoung, I'll get out of your way, and you can land the ship here. Thank you guys so much.
No, I was just gonna say, but it is the conference is an in-person event, correct?
Yes. But yeah, you can watch the live stream of the keynote generically, and then we'll eventually publish all of the session videos online.
Great. Yeah. So, I mean, that's it for me. If there's are no other questions, I know there's been some comments in the comments sections, but so Patrick, I'll leave it up to you to wrap up and to make any other announcement as we close. And Brian, thank you so much for spending an afternoon with us. It's been really informative, and so we really appreciate your time here today.
Okay, you're welcome. Thank you.
There we go. I was on mute. Yeah, thanks again, Brian, for coming out. It was a pleasure to have you at AWE. I think the last time we had someone from Niantic was Ross from about 2 years ago, and that was a great time. So really appreciate the support. Yeah, for everybody out there, I guess make sure that once again, hashtag AWE Night SF, put it out there into the social channels, get your tickets for AWE, and go check out the Niantic event. Like, I really wish I could be there, but I will be traveling, so I'm disappointed myself. So anyways, that's our show. So thanks again, everybody, and we'll see you next time.